Good morning, everyone. My name is Teja and thank you for being here. Today, I will be presenting my project on sales forecasting using Apple Sales Dataset 2024. This project is part of my CSIS 5420 Machine Learning for Business Analytics course under the guidance of Professor Deepak Viskatwala. The goal of this project is to use machine learning models to predict Apple's future sales and service revenue based on historical data from various global regions. Introduction. Sales forecasting plays a crucial role in business decision making, helping companies optimize inventory, marketing strategies, and resource allocation. In this project, I analyzed Apple's product sales and service revenue across multiple global regions for 2024. Using various machine learning models, I aim to predict future sales trends and determine which model provides the most accurate forecasting. This approach enables Apple and similar companies to make data-driven decisions, ensuring maximum profitability and efficiency. Problem statement. Businesses need accurate sales predictions to manage supply chain operations efficiently and reduce losses due to overproduction and understocking. Apple's global product sales dataset provides valuable insights into customer trends, but manually forecasting methods are often time-consuming and inaccurate. The challenge is to develop a reliable and efficient machine learning model that accurately predicts Apple's sales figures. By applying machine learning, we can improve forecasting accuracy and identify key factors influencing revenue. The dataset contains 1,000 records detailing Apple product sales and service revenue across different regions. The key attributes in the dataset includes region, iPhone sales, iPad sales, Mac sales, and variables and service revenue. The service revenue generated from subscriptions and Apple services measured in billions, and the iPhone sales, iPad sales, Mac sales, those are all measured in unit sales in millions. That dataset allows us to analyze regional trends and predict future sales performance. Data preprocessing. So what is data preprocessing? Data preprocessing is nothing but before applying machine learning models, we must prepare the data for analysis. The data preprocessing it includes several steps, that is data cleaning. In the data cleaning, we replace the missing values using missing value operator in a rapid manner to handle missing values. Re- uh, we, we also remove duplicate entries to ensure data consistency. We also convert the categorical variables such as regions and some other variables to numerical by using nominal to numerical operator. And we also create additional features based on the sales trends to enhance predictive power. And the another step that is included in data pre-processing is data splitting. So the dataset was split into 70% for training and 30% for testing. We used split data operator to split the data. Machine learning models used in the project involves 4 different machine learning models. So we used 4 different machine learning models. Those are linear regression, decision trees, random forest, XGBoost. Linear regression, it predicts continuous values using historical data, and decision trees is a rule-based hierarchical structure for making predictions. The random forest is an assemble of multiple decision trees for improved accuracy. The XGBoost, it is a model uh, that a gradient boosting algorithm optimized for a structured data. So the first model, that is linear regression model. What is a linear regression model? In simple terms, linear regression is a statistical method for modeling the relationship between a dependent variable and one or more independent variables. So this is a process. So first we have loaded the data using retrieve operator, and we have converted the nominal values to numerical values, and we have selected set role operator from the operators, and we have set a role, like we set a target, and we have set a prediction values, like prediction columns, and we applied the linear regression operator and used the performance regression operator to evaluate metrics like MAE, MSE, and R squared. So this is the output after we have run the model. So it states that the state, if we look at the attributes column, so the first attribute is state. So the coefficient of state is 0.041 and the p-value is 0.09. It, it says positive impact on sales. That is, a unit increase in state results in a 0.041 increase in sales. And it is statistically significant because the p-value is less than 0.05, meaning this variable is relevant in predicting sales. Next, moving on to region, we can see the coefficient is minus 0.043 and the p-value is 0.572. It says negative impact on sales, that is, a unit increase in region leads to slight decrease in sales. Not statistically significant, that is, p-value is less than 0.05, meaning it may not be a key predictor in the model. Next, we can see the iPhone sales. The coefficient of iPhone sales is minus 0.038 and the p-value is 0.013. It is surprisingly negative impact on sales, means this could mean iPhone sales are correlated with other factors affecting revenue, and the p-value is less than 0.05. It is relevant in the model. And the service revenue suggests that Apple's service revenue is weakly related to overall sales in the dataset. And the key insights from the output are: state has a positive impact on sales and it is statistically significant. iPhone sales have a negative coefficient, which might indicate that other variables should be included to better capture trends. And the region and service revenue are not statistically significant, meaning they do not strongly impact sales predictions in the model. Intercept is significant, which suggests that other unaccounted factors might be driving sales. Next, moving on to decision tree model. It is a hierarchical structure that makes predictions by splitting data at a key decision points. That is, it uses the technique uh, that assemble learning method that builds multiple decision trees sequentially, where each new tree corrects the errors of the previous ones. So we can see the process here. Uh, as a previous model, we have loaded the data and we have converted the nominal to numerical values, and we just use the gradient boosted trees operator. So we have configured the number of trees to 26 in the parameters of the gradient booster trees for refined predictions, and adjusted the learning rate is equal to 0.1 to control the step size in boosting. And we have used performance regression operator to evaluate accuracy. So understanding the GBT output, multiple trees in the left panel. Unlike a single decision tree, GBT constructs multiple trees sequentially. In the case, it is 26. Each tree corrects errors from the previous tree, making the final model more accurate. So the decision path, which is on the right, the tree diagram shows how predictions are made by splitting the data at different points. Each node, a feature, example service revenue, iPhone sales, state, is used as a decision factor. The leaf node, final branches, represent predicted values. This services revenue in billions appears at the top of the tree, meaning it is the most influential feature in the predicting sales. And the state and iPhone sales also contribute significantly, appearing in the multiple splits. So the key insights from the GBT model is services revenue plays the most critical role in predicting Apple sales. State and iPhone sales are also major contributing factors. GBT outperforms other models like random forest linear regression in the prediction accuracy. Next, moving on to random forest model. It is a technique that builds multiple decision trees and averages of their results. So you can see the process here. We have used the random forest operator, and we have configured the number of trees to 20 for balanced learning, and we have adjusted the maximum depth to control overfitting, and used performance regression operator to evaluate accuracy. This operator trains multiple decision trees in parallel and averages their predictions. So the key parameters are number of trees. We have set the number of trees to 20, means we have we will get the balanced accuracy and computational cost. And we have set the maximum depth in the parameters of the random forest operator to controlled to prevent overfitting. And we have used the sampling bootstrap to improve the model generalization. And we have used the performance operator to evaluate the root mean square RMSE, and we have selected the R squared. So this is the output after running the model. So in the left panel you can see the multiple trees. Unlike a single tree, uh, random forest creates multiple trees independently. In this case, the trees are 20 trees, and the final prediction is obtained by averaging predictions from all trees, reducing the overfitting. On the right side, we can see the decision path. The tree diagram shows how predictions are made based on the different features. The root node is iPhone sales in million units, meaning it is the most influential factor. Other important features include iPad sales, Mac sales, state and region. It helps refine predictions based on location. The Mac sales contribute significantly in indicating demand for larger Apple devices. And the iPad sales is another critical factor in predicting revenue. So we can see iPhone sales has the highest impact, appearing at the top of the split, and iPad and Mac sales also plays crucial roles, appearing in the multiple splits. And region is used to differentiate patterns in certain cases, helping localize predictions. And The key insights from the random forest model output is iPhone sales, iPad sales, and Mac sales are the top predictors of the revenue. And the random forest is more stable than a single decision tree and avoids overfitting. Compared to the decision trees previously used the model, uh, that is GBT, gradient boosted trees, it has slightly lower accuracy but provides more interpretability. Next, moving on to XGBoost. So XGBoost, extreme gradient boosting, is an advanced assembling l- learning method that improves prediction through gradient boosting. It refines each decision tree in the sequence by minimizing residual errors from previous trees. It is also known for its high efficiency, scalability, and better handling of missing values compared to traditional models. So this is a process. The algorithm starts with a weak decision tree and iteratively improves it by adjusting the errors of previous trees. It assigns higher weights to misclassified samples and ensuring the model focuses on difficult to predict instance. So we can see the process. We have imported the dataset using uh, red read CSV operator and applied XGBoost operator to construct the regression model. And we have tuned the parameters such as hyperparameters such as maximum depth to 6. It controls tree complexity, and we have uh, learned the rate to 0.3. It controls how much the model adjusts in the each iteration. Boosting iterations. We have set the boosting iterations to 25. Number of times the model updates itself is 25. The maximum value is 25. It can't go beyond 25. And we have evaluated the uh, model using performance regression operator. So this is the output we got. So tree method. This indicates the hist. Indicates the use of histogram based algorithm for optimized training, which speeds up computation, especially for large data sets. And the maximum depth we have observed is 6. The model was allowed to grow up to depth of 6, ensuring a balance between capturing complexity and preventing overfitting. And the booster is GB tree. The primary learning approach is based on gradient boosting trees, which sequentially improve performance by correcting the errors of previous trees. Learning rate is 0.3. A relatively high learning rate was used, which means the model updates weights more aggressively but may require more tuning for stability. Lambda is 1.0. L2 regularization was applied to prevent overfitting, ensuring the model generalizes well on new data. Uh, the key insights from the model are iPhone and iPad sales strongly influence Apple's revenue predictions. Random forest and XGBoost significantly improved forecasting accuracy, and the gradient boosted tree uh, provided the best overall predictions. We can see that the GBT provided the best overall predictions in the comparison. Gradient boosted tree provide the most accurate predictions. Sales forecasting using machine learning is highly beneficial for business strategy. Um, and the optimized model hyperparameters for better performance. Incorporate economic indicators such as inflation and GDP. Develop a real-time uh, sales prediction system for Apple. Thank you for your time. This project highlights the importance of machine learning in business analytics and forecasting. I'm happy to answer any questions. Thank you.